Okay, fine. Hello everyone, and welcome to our today's session on maths 2. That is, we'll discuss all the units, 3 units, and the different concepts. Okay, so I'll just give you a proper overview of how to solve the questions as well in exam, the appropriate weightage and everything. Fine. Let's begin. So basically, as you all already might know, we have 3 units, that is partial differentiation, multiple integration, and vector calculus. Okay. So first of all, we have partial differentiation. What is partial differentiation? Before that, let's just revise that what is differentiation. Differentiation is a fundamental concept which was basically introduced to us back in class 12 itself. For what is a real life analogy or example of differentiation? Basically, how we imagine you have a iron rod, and from that you need to cut it into small pieces. So you just even in the workshop subject you have this thing, right, where you have to weld. So even without welding, if you have to cut into small pieces, that is differentiation. That is, you break down a big thing into small entities, such as this entire PDF. It comprises of 26 pages. And now what we have done, we have differentiated it into unit pages. So now this is differentiation ka basic notion. That is a big thing. You break down into smaller portions. Okay. Now what is partial differentiation? Okay. Basically, in partial differentiation, um, now imagine that I have to pay rupees 50 to a shopkeeper. So I have a combination of coins, okay, certain number of coins. I have a few 5 rupee coins as well as a few 10 rupee coins. So when I present my combination, imagine I have 2 coins of 10 rupees and 6 coins of 5 rupees. So if we denote them by X and Y, we are presenting a combination of X and Y to the shopkeeper. Keep this, take this. Its total is 50 rupees. But what if the shopkeeper wants to find out individually how many coins of 5 and 10 rupees are there? In that case he needs to just basically in that case he needs to apply partial differentiation. According to your curriculum, what are there? Let's go through it step by step. Firstly, we have function of two or more variables. A single variable function, that is y, can be expressed in terms only of x. Example, y equals to x squared plus 2x plus 1. And a multivariable function, that is z equals to f of x comma y, or w equals to f of x, y, and z. So what is this? Example, f of x comma y equals to x square plus y square. This gives us a surface in 3D space. So we know x square plus y square equal to a square is the equation of a circle, right? So similarly, this gives us a surface in the 3D space. And multivariable is like another example, f of xyz equals to x plus yz. So here there are 3 variables which are expressed as a single function. Again, if I write y equals to 2x plus 3, then it is a single variate or single variable function. Then we have what is a homogeneous function. A function fxy is a homogeneous function of degree n if f of tx comma ty equals to t to the power n f of x comma y. Now this is something which is a very possible or potential question of, like, it can be asked for 2 or even 5 marks. Okay, if it is a bit complicated, it can be even asked for 5 marks. That is your section B ka first question. In that case, what you need to do, simply such a way f of xy will be expressed. Then what you have to do, instead of x comma y, you have to multiply both x and y by a constant, that is t or a b c, anything, a constant you need to multiply. Then in this particular equation, that is the RHS, you need to substitute the x as tx, that is here it was x cube and here we have tx cube, and y as ty. So that way if we keep solving, we'll finally get what, t cube comes outside as a common thing, and x cube plus y cube stays inside the bracket. So the power of this polynomial is now 3 because it's the highest degree. So this degree of this homogeneous equation is 3. Okay, so if you understand now the simple concept, you're already guaranteed 2 or 5 marks. See the second example now, f of xy equals to x square plus 3xy plus y square. Now what if you multiply the entire thing by t? So f of tx comma ty equals to t squared x square plus 3t squared xy plus t squared y square. So if you take t square common, you again get what? F of xy only. So its degree is 2. Now, what is an example of a non-homogeneous equation? Here, if we multiply x and y by t, a, b, c, anything, no, ultimate final equation does not sum up to be the thing because it becomes tx whole square, that is t square x square, t into y plus 3. Now, many of you may ask, ki, why is this not 3t? Why is this just 3? Because you see, there is no constant parameter in the bracket. The parameters are just defined for x and y. So t is only, associated to x and y and not the constant, that is 3. So these are homogeneous and non-homogeneous equations. Okay. Then a very important concept we have, Euler's theorem for homogeneous functions. So if f of x comma y is a homogeneous of degree n, that is f of tx comma ty equals to t to the power n f of xy, then what does this say? Then x of del f del x plus y of del f del y equals to n of fxy. What does this mean? Look, firstly, why is this del being used here? Okay, this opposite 6. Simply because dx, dy or anything which consists of d, that means total differentiation or complete differentiation. But del means partial differentiation. So you must even have seen in physics that in most places we use del instead of d. Why so? Because sometimes you don't need to completely differentiate, we just need a part of it or a portion of it. So for example, we have to check for Euler's theorem in this. Okay, we check for homogeneity, that is f of tx comma ty. We have this particular function x square y plus y cube. So then what we do, we replace x and y by tx and ty, and then we check कि t का कौन सा degree comes common such that this particular expression can be obtained again. Okay, okay, if some of you still have doubts ki what is this homogeneity thing, just remember a simple thing, like for example, you've gone shopping, and while going to shopping, you have two particular bags. Now what they do is they put a tag on your bag ki okay, now you can't open your bag while shopping, that is you can't put anything from the shop into your bag. Now, after shopping, you again open that tag. Okay, you open the tag and give it back to the shopkeeper. What you get? You get your original bag back. No, you don't get any extra things inside your bag, or you don't get anything outside your bag. The bag is original as it was earlier. Similarly, here f of x comma y does not get changed, whatever constant comes. Okay. So that's the basic notion of homogeneity and verify Euler's theorem. So basically you first check for homogeneity in Euler's theorem questions. Okay. Whatever question comes from Euler's theorem, you first have to check whether it's homogeneous by checking the degree of the given equation. Okay. Then what you need to do, we need to verify Euler's theorem. That is del of f by del of x and del f by del y. Both you have to evaluate, and then what you have to add them, and then find कि जो degree है, if it is multiplied by f of xy, does it give the same result as this sum or not? So this is a obviously pretty crucial concept, and I'm sure most of you must already have done it while preparing for MST1. So next up we have what is composite functions and chain rule. So what is a composite function? If z is equal to f of u comma v, where u equals to g of x comma y and v equals to h of x comma y. Now, what does this all mean? Yeah, like why is all letters and all used here? So basic thing you see, okay. What do we have here? We have del z by del x. And if you see here also we have del z del x in diagonal fashion, okay. And here also we have del z del x in a diagonal fashion. So basically what, when you learnt fraction multiplication, we know कि one numerator, if both numerator and denominator of a fraction being multiplied are same, we cancel them off. So even if you see here, we'll get del z del x plus del z del x again. So both the halves will result in a whole del z del x, because here du will get cancelled and here dv will get cancelled. So why is this composition used? Okay, now look at a simpler example of composition. Okay, it's like saying I have to go from the main gate to your block C1, because I believe most of you who are attending this session belong to block C1. Now, while going to block C1 from gate 1, next Monday and Tuesday there is U Fest. So I have to visit the Fountain Park as well. So from main gate, I first go to Fountain Park, that is this, plus from Fountain Park I go to block C1, that is the second part. So ultimately आप main gate से C1 ही पहुंचोगे, just there's a small junction in between, that is the Fountain Park. So that way what happens, you just simply go to the main place. Okay, so then we have an example कि जहाँ Z का formula दिया है and U and V, but what is the problem here? कि we need to find del z by del x, but in the expression of z there is no x or y. In the expression of z there is no x or y. So what you need to do, you need to further, like chain rule also was a part of your class 12 syllabus. So similarly you need to substitute u and v according to the given formula. Okay, then we have implicit functions and differentiation. Now, what are implicit functions? Okay. So basically what happens, given f x y z equals to 0 and z equals to f of x comma y. So if I say ki, like if we use implicit differentiation, then this dz dx equal to minus df by dx whole by del f del z. Because see, ultimately, if you use the simple fraction division concept once again, del f will get cancelled, and here too del f will get cancelled, and del z will go up, del y will come to the numerator. Now, what is f? What is this capital F? F is the function which will be given to you in the question. So that way, what you will need to find, if f is given to you, you will simply need to find del f del x, del f del y and del f del z first, and then again you need to find del s del z del x. Now this is a bit tricky because this concept is a continuation of your earlier concept, that is composite functions. So this can also be asked for 5 marks. And the final topic of this chapter, total derivative. So total derivative is also a following of the chain rule only. Okay, where you follow this given function. So you can just follow this example where we differentiate z with respect to x and y, and then we add them up, okay, to find del z, del t, del y, del t, etc. And change of variables. Now, why do we need to change variables? Because in second unit, that is integration, double integration, multiple integration, you have seen how like we use polar coordinates, right? So it is basically the same thing. That is, we are using double, like change of variables to simplify the things. Okay, now imagine it's a Wednesday or you have a formal assessment examination. So what you do? You have to go to college wearing the uniform, right? Wearing the uniform does not change you or your properties. It is just an, explicit addition to your appearance. Similarly, sometimes we have to change the variables also so that they suit the function as per the changes. Up next, we have Jacobian. A Jacobian is a determinant representing how a function transforms under variable substitution. So here we have done change of variables, right? But changing variables is not so easy. For this, we have to take up Jacobian. So Jacobian का formula इधर है कि this is basically a quadrilinear thing. So here we have to find the Jacobian. So you can simply see that if two things will be given in question. Okay, let's see. Find the Jacobian of the transformation r cos theta and r sin theta. So basically you just first find कि आपको Jacobian निकालना किसका है. Firstly, x comma y divided by r comma theta. So you can simply replace the things in the given formula to use them to find the Jacobian. So after every chapter in this particular sheet, I have attached 10 numericals or 10 questions. So that would help you to get accustomed to the entire PPT so that you can practice. Okay. So determine whether this is a homogeneous. So you know how to do it. Euler's theorem, then file dz dt. This is a composition thing. Then again, it is a composition question. Given f of xyz equals to this, find dz dx. So that way, this first chapter is done. It's basically fully arithmetic. Now that we have learned so many properties of partial differentiation, where are they used? Now, second chapter is something which you'll need to do by yourself. Like this is not something I can just explain verbally. You have to practice it yourself. So the formula I've attached here along with some, elementary examples. So what is the Taylor's and Maclaurin's series? If f of x comma y is a function with continuous partial derivatives, then the Taylor expansion about point AB is this. Now I assume most of you are in the CSC department, right? So next year itself, that is in second year, you will get these applications of series in subjects, in the core CSC subjects also. Now what we see here, if A and B equal to 0, this becomes the Maclaurin series. So in this entire formula, if we put A and B equal to 0, that is about the origin, then it becomes the Maclaurin series. Then we have maxima and minima of functions of two variables. So what is the maxima and minima? The process is simple. First we will be given a function whose first derivatives we have to equate to 0. Then we have to compute the second order partial derivatives. That is like a equals to del f, del 2f, del x square, del y of del f del x, and del square del y of f square, like that. Okay. Now look, then we have this entire sum based on how to solve the maxima minima problem. Now I'll just share a small trick with you guys. Okay. देखो आप लोगों को ये तो पता है कि मैक्सिमम मतलब ग्रेटेस्ट. ग्रेटेस्ट से आप कौन सा सिंबल एसोसिएट करते हो? द ग्रेटर देन सिंबल, राइट? तो इतना याद रखना कि मैक्सिमा और मिनिमा के केस में द साइंस आर इन्वर्टेड. दैट इज अगर ग्रेटर देन साइन हुआ, then it will not be maxima, it will be minima. That is, if d is greater than 0, it's the local minimum. और मिनिमा सुनने से हमें दिमाग में क्या आता है? लेस देन होगा. मिनिमम मतलब छोटा. लेस देन मतलब मैक्सिमा होगा. सो अगर आपको है डी इज लेस देन जीरो, देन इट इज ए इज लेस देन जीरो, देन इट इज द लोकल मैक्सिमा. सो इसका बेसिक मतलब क्या है? जैसे आपका सोचो रेंज है 0 to 90 और आपको मिला 89. अब आपको 89 इज लेस देन 90 है ना? तो 89 will be the local maximum and 1 is greater than 0, so 1 will be the local minima. So basically ये एक important topic है 5 marks के लिए. Okay, even 10 marks के लिए. I think हमारे batch में this particular maxima minima thing came for 10 marks. So ऐसे क्वेश्चन दिया रहेगा आपको, इसका मैक्सिमा मिनिमा या सैडल पॉइंट्स ढूंढने हैं. व्हाट आर सैडल पॉइंट्स? इफ अगर डिटर्मिनेंट इज लेसर देन जीरो, मतलब इसके बाद और सॉल्व ही नहीं हो पाएगा. This is the thing of local maxima and minima. And another thing which is a totally formula based aspect is Lagrange's method of underdetermined multipliers. So आप ये वाला concept जो है basically what we do, एक फंक्शन आपको क्वेश्चन में दिया रहेगा जो आपको ऑप्टिमाइज करना है, ओके। एंड एक फाई नाम का एक और फंक्शन आपको कॉन्स्ट्रेंट दिया रहेगा। सो व्हाट यू नीड टू डू, यू नीड टू मल्टीप्लाई them all by a thing, by a constant that is alpha, sorry, lambda, and then you need to solve it accordingly. So I have given another example here. Lagrange is, to be very honest, Lagrange is not so important or like from your exam POV, because I don't think they will give. What is important is the maxima minima for 10 marks, okay? And also the Maclaurin series, because at our time Maclaurin came for 5 marks and this maxima minima came for 10 marks. So do it very well. Okay, then do this Lagrange. I told you it's not so important, but try like solving this particular one. It's mainly from the linear optimization things which you did in the previous classes. Next comes unit 2, multiple integration. What is multiple integration? Single integration. The rod wala example which I gave you at the extreme starting, that is you break down a rod into small pieces. Now that you have the small pieces, okay guys, just a second. Can you please give a reaction or anything like I'm audible no, properly and the presentation is visible? Okay, thank you Herman for your reply. Yes, Vansh, thank you. So, okay, fine. So I'll continue. So unit 2, multiple integration. So double integral is what? You already have an integration and you are integrating that integration once again. So देखो इसके अंदर एक integration है already dx. तो आप dx से लेके पहले वाले को integrate कर रहे हो, उसके बाद एक और बार integration को ही फिर से integrate कर रहे हो. So double integral usually represents the volume under the surface z equal to fxy over the region R. अब इवैल्यूएशन तो आप सबको आता ही होगा इसका डबल इंटीग्रेशन का. देयर इज नो पर्टिकुलर ट्रिक आई कैन गिव यू, ओके, यू जस्ट हैव टू डू इट स्टेप बाय स्टेप. अब देखो इतना बताऊंगा कि पहले इधर किसका इंटीग्रेशन हो रहा है, डी वाई के रेस्पेक्ट में, ओके. सो इधर क्या होगा, एक्स कांस्टेंट ट्रीटेड होगा तो एक्स बाहर आ गया, इंटीग्रेशन ऑफ डी वाई इज वाई, सो दिस इज एक्स वाई एंड फिर से वाई स्क्वायर, सो दैट वे यू गेट एन एक्सप्रेशन. अब इसको आपको एक्स के रिस्पेक्ट में इंटीग्रेट करना है, सो यू गेट दिस. सो बेसिकली आपको एक ही बात मैं बताना चाहूंगा कि मल्टीपल इंटीग्रेशन देख के डरने की कोई बात नहीं कि इट्स अ वेरी डिफिकल्ट चैप्टर. जिनको आपको लगता है कि आपकी कंसेप्ट सिंगल इंटीग्रेशन की क्लियर नहीं है, आई विल स्टिल सजेस्ट आप लोग अभी भी टाइम है, सिंगल इंटीग्रेशन के कंसेप्ट सुधार लो. बिकॉज मल्टीपल इंटीग्रेशन इज मोर अबाउट सिंगल इंटीग्रेशन, बिकॉज इट्स लाइक अ कंपोजिट फंक्शन ओनली, कि आपको बहुत सारे सिंगल इंटीग्रेशन कर करके आपको मल्टीपल इंटीग्रेशन आएगा. देन वी हैव चेंज ऑफ ऑर्डर ऑफ इंटीग्रेशन, द सेम थिंग कि जैसे इस वाले सम में हमने पहले डी वाई मतलब वाई को इंटीग्रेट किया, फाइनली हमने एक्स को किया. बट व्हाट इफ हम डी एक्स को पहले इंटीग्रेट करें और डी वाई को उसके बाद, तो उसी का कंसेप्ट आता है इन द थिंग ऑफ चेंज ऑफ ऑर्डर. सो जैसे चेंज द ऑर्डर एंड इवेलुएट दिस थिंग, ओके. तो इधर क्या है, पहले एक्स है और फिर वाई है. वाई की लिमिट्स क्या है, 0 से 1, बिकॉज वाई की आउटसाइड है, तो वाई की लिमिट से 0 to 1 और एक्स की है वाई से 1 तक. अब अगर एक्स बाहर चला गया तो एक्स की लिमिट क्या हो जाएगी, 0 to 1, बिकॉज एक्स इज गोइंग आउटसाइड. और अगर x is 0 to 1, then y will be from 0 to x, because 1 is now replaced by x. So then we can just solve this sum, and most cases में देखा जाता है कि change of integration order helps us to integrate it more efficiently, because पहले ही हम अगर x को लेके integrate करें तब थोड़ा इस sum में दिक्कत आएगा. So just see all the questions properly and then apply them, so that you know where to change the order. Up next we have triple integrals. It is used to evaluate the volume in 3D space. So basically it's like आपने एक रॉड को इंटीग्रेट किया छोटे छोटे टुकड़ों को जोड़ के. अगेन अब जो आपने जोड़ के एक रॉड बनाया, वैसे आपने कई सारे रॉड्स को एक साथ जोड़ के एक शीट बनाया. इट्स लाइक देखो रूबिक्स क्यूब जो है आपके पास, रूबिक्स क्यूब का एक छोटा सा ब्लॉक है, द स्मॉल 1 सेंटीमीटर बाय 1 सेंटीमीटर होल क्यूब. उससे आपने पहले एक सरफेस बनाया 9 स्क्वायर्स वाला. फिर वैसे तीन और स्क्वायर्स को आपने बना के 3 by 3 क्यूब बना दिया. सो दैट्स अ बेसिक नोशन ऑफ ट्रिपल इंटीग्रेशन. उसके बाद आता है जकोबियन मेथड. सो एज आई टोल्ड यू, मैथ्स में एवरीथिंग इज इंटररिलेटेड. जकोबियन भी इधर क्यों आ रहा है, दैट्स वेरी क्लियर टू अस. देन चेंज ऑफ वेरिएबल्स जो हमने यूनिट 1 में पढ़ा था, ये उसी का कंटिन्यूएशन है. So again we have some practice questions. So guys, these practice questions मैंने ऐसे ही कहीं से भी उठा नहीं लिए. Some of these are PYQs also, and these were done by our class, मैंने our teacher also. So just try doing this now. Okay, don't keep this कि मैं एग्जाम के एक दिन पहले करूंगा या करूंगी. Because what happens, एग्जाम का एक दिन पहले is actually not for solving, that's for revising. So now time is still there. You please start doing this, and I would myself suggest कि पहले डबल या ट्रिपल इंटीग्रल से पहले आप सिंगल इंटीग्रेशन के सम्स या फॉर्मूलेस को रट लो. Because trust me, mathematics 2 is a very scoring subject, especially compared to mathematics 1 जो आपके फर्स्ट सेमेस्टर में था. सुनने से आप सबको मतलब you can feel it weird, but yeah, I myself scored 11 out of 20 in MST2 of Maths 2, but the same me scored 59.5 out of 60 in the EST. Okay, so you can if you have the thing. Because पहले MST2 मेरा भी खराब गया था, but that did not stop me कि I'll stop practice, I don't know integration, no. फिर मैंने MST2 के बाद स्टार्ट किया सिंगल इंटीग्रेशन को प्रैक्टिस करना, रिवाइज करना फ्रॉम क्लास 12 एनसीईआरटी, एंड दैट वाज डेफिनेटली हेल्पफुल. एंड बिकॉज इंटीग्रेशन अभी तो बस इधर यूज हो रहा है, बट नाउ दैट आई माई सेल्फ आई एम इन फोर्थ सेमेस्टर, आपको थर्ड और फोर्थ सेम में स्टैटिस्टिक्स भी मिलेगा, और स्टैटिस्टिक्स इज फुल ऑफ इंटीग्रेशन इन क्लास मैंने इन थर्ड एंड फोर्थ सेम. So please clarify the concepts. Chapter 4 is again applications of multiple integral. पहले डबल इंटीग्रेशन यूज करके एरिया निकालना कैसे है. सो क्वेश्चन दिया रहेगा, फाइंड द एरिया बाउंडेड बाय द पैराबोला दिस एंड द लाइन दिस. सो पर्सनली माय रिकमेंडेशन इज कि आप लोग ग्राफ बना लेना. छोटा सा होने से भी कोई दिक्कत नहीं, जो लाइंस दी हुई है उनसे कोई ग्राफ बना लेना. दैट वुड हेल्प यू टू विजुअलाइज कि आपको एरिया एक्चुअली कहाँ का निकालना है. एंड प्लस बोनस मार्क्स के भी तो प्लेस हो ही जाते हैं इफ यू ड्रॉ इट करेक्टली, बट योर सम इज रॉन्ग, यू स्टिल गेट हाफ द अलॉटेड मार्क्स. ओके. देन वी हैव वॉल्यूम अंडर डबल इंटीग्रेशन. तो वॉल्यूम हम कैसे निकाल सकते हैं यूजिंग डबल इंटीग्रेशन, यूजिंग द फंक्शन ऑफ एफ ऑफ एक्स कॉमा वाई, दैट इज जेड. So we have another example also here कि हमने कैसे निकाला. Then we have volume using triple integration. Mind you, double and triple integration का volume अलग है, because triple integration में आपको z का एक फॉर्मूला फॉर्मुलेट कर लेना पड़ेगा. And then again we have another volume. So basically the second chapter is all dealing with volumes and areas. So basically आपने ज्योमेट्री में तो पढ़ा ही होगा एरिया और वॉल्यूम के फॉर्मूलाज क्या है, आपको वो सब अभी अप्लाई करने हैं. सिलेंडर हो कुछ भी हो, आपको एक डायग्राम बना के पहले विजुअलाइज करना है. एंड अनदर थिंग विच यू नीड टू डू फ्रॉम यूनिट 2 चैप्टर 2 is those special kind of graphs, that is cardioid, this, that. I'll share that as well with you guys. Okay. So this is all about the second chapter of unit 2, that is multiple integration. ऐसे questions हैं, and these are very probable to come for 10 marks. This 9 and 10 ऐसे टाइप के problem sums आने का chance maximum है, because they are not going to give you simple sums and leave you कि okay done. No. Okay, so finally we start with the new unit, that is vector calculus. अब वेक्टर कैलकुलस यूआईज आर आप लोग अनजाने में इसके साथ फैमिलियर हो, बिकॉज आप लोगों ने ये क्लास 12 की फिजिक्स में कर रखी है. अब डायरेक्टली नहीं, बट फर्स्टली लेट्स इंट्रोड्यूस आवरसेल्व्स. सो गाइस, till now how's everything been? Please react or chat. Okay, thank you Harman once again. Thank you Vardhan. Okay, so we'll move on to unit 3, that is vector calculus. What is vector differentiation? So differentiation was the whole main point of the unit 1. So what are scalar and vector fields? Scalar fields assigns a scalar value to every point in space, and vector field assigns a vector to every point in space. वेक्टर तो आई जे और के है एंड दैट नथिंग like nobody else knows it better than class 12 के physics pass outs because this I J and K firstly class 11 की physics and secondly class 12 की maths में these just got रग रग में समा गया था अपने अब नेक्स्ट वे हैव डिफरेंशिएशन ऑफ वेक्टर्स सो एक आर ये है हमारे पास इसका फर्स्ट डिराइवेटिव क्या होगा फर्स्ट डिराइवेटिव होगा वेलोसिटी जहाँ t इज द टाइम ओके सो टाइम के रेस्पेक्ट में आप डिफरेंशिएट करोगे आपको वेलोसिटी मिलेगा सेकंड डिराइवेटिव होगा एक्सेलरेशन नेक्स्ट इज द डेल ऑपरेटर डेल ऑपरेटर इज दिस थिंग जहाँ जिसका यूज ग्रेडियंट में होता है ना व्हाट इज ग्रेडियंट ग्रेडियंट में आपको क्या होगा फाई नाम का एक फंक्शन दिया रहेगा जैसे दिस एक्स स्क्वायर प्लस वाई स्क्वायर प्लस जेड स्क्वायर अब डेल ऑफ फाई इक्वल टू डेल डेल एक्स ऑफ फाई आई कैप मतलब इधर देखो इसको अगर आप लोग x के रिस्पेक्ट में डिफरेंशिएट करोगे तो ये होगा 2x प्लस जीरो मतलब 2x और आई कैप so 2x I cap plus similarly if you differentiate this entire expression with respect to y and then add a j cap then it becomes the second element and so does the third element. So this is the basic notion of gradient or grad. Thirdly we have what is divergence. Now, divergence is what? Divergence of a field is this, like basically divergence and gradient are the same things. Just divergence में क्या होता है? Divergence में आपको I, J और K से कोई नाता नहीं रहता. You can simply, differentiate it with the respect, and then you have to cancel the I, J and K. Now, divergence is what? Divergence is the dot product of del and f. That is the directional vector, right? Okay. Up next, we have the concept of curl. Now, what is curl? Divergence जैसे इन दोनों का dot product था, curl is the cross product. That is, इसमें I, J और K तीनों involved रहते हैं. So, what does curl do? Curl measures the local rotation or circulation of a field. Okay. So then we can simply you can see how we have like calculated the divergence and curl of the given equations. Okay. So now there are certain identities which we must remember. So identities just say this, okay? That is del into del. That way we can find the Laplacian of scalar. Now Laplacian is not there in your course, but yeah, these formulas you guys please remember. कि divergence क्या है, curl क्या है, कौन सा dot product है. Now remember divergence मतलब dot. D for divergence, D for dot. C for cross, C for curl. Okay, C for cross, C for curl, and D for dot, D for divergence. So that's all about the first chapter of your third unit where you have to you deal with just the dot products and cross products everywhere. Your vector geometry or vector algebra needs to be very clear. Okay, so these kind of 2 or 5 mark sums will be asked from this chapter. Now let's move on to the 10 marks thing that is vector integration. Now what is a line integral? Line integral is an integral of a vector field along a curve. ओके सो बेसिकली आप अगर एक बॉल को एक सर्कुलर पाथ में घुमाते रहोगे एंड सडनली आप अपना हाथ उठा लोगे देन दैट बॉल विल टेंड टू मूव इन अ स्ट्रेट पाथ सडनली ओके इट विल बी टेंजेंशियल टू द circular path. So that's the basic concept of a line integral. Okay. Next we have a surface integral. That is surface integral is the integral of a scalar field or vector field over a surface. It generalizes the concept of the flux of a vector field through a surface. Okay. So it's also like the same example I gave earlier for line integral. And volume integral is the same thing. अब देखो line integral में basically एक single integration होता है, surface में double और volume में triple. I'll be sharing a formula chart with you guys which will help you ease the concepts. And flux इसका definition is very important. You just go through it well. And solenoidal and irrotational vectors. A vector is solenoidal if its divergence is zero and irrotational if its curl is zero. Guys, mind you, this is the easiest thing of this entire chapter, okay? Unit 3 is the easiest among your three units. Just if you have the basic concept clear. So these things, if it comes for 5 or 10 marks, you are blessed. Okay, you can't, nothing can stop you from getting 60. Just please prove the dot product is 0 and prove the cross product is 0 to prove them as solenoidal or irrotational. Okay. Then we have the three theorems who we have to study because the three of them are dealing with three different things. गॉस डाइवर्जेंस में आपको डबल इंटीग्रल को ट्रिपल में प्रूफ करना है. ग्रीन्स थ्योरम में आपको लाइन को एक सरफेस इंटीग्रल बनवाना है और स्टोक्स में भी आपको लाइन इंटीग्रल बट सरफेस करना है बट इसमें द लाइन इंटीग्रल इज बाउंड. ओके, नाउ इनमें समझाने का ज्यादा कुछ है नहीं. जस्ट द see the RHS is different. Here it is this and here it is this. In both the theorems, the RHS is different. Now, many of you asked me, ki, sir, is the theorem important for exam? So, yeah, some is sure to come, but about the theorem, you may be asked for 2 marks. State Stokes theorem. And about, I'm seeing your analogy of type of questions coming in your exams. I suggest you do go through this well, okay? Then we have the practice questions. So you can just try them out because this entire unit is just based on the idea of integration, differentiation, and divergence and curl. Okay. So that way, if you do these practice questions, we are done with chapter 6 as well. So here I've given 15 questions for the, final, that is question bank for mathematics 2. So that way it would be easy for you guys to prepare for your finals. Okay. So currently I'm in a little bit of hurry. So I'll just keep it till here today. If you guys have any doubt, you can just let me know in the chat box. I'll stay online for the next 3 minutes. Okay, sir, please provide this PDF in community for practice. Yeah, sure, I will. And besides, I'll also provide you guys with a uh, that thing with sample question papers for your EST. Okay, by tomorrow I'll upload, and I hope you guys have already seen how the FED notes also I uploaded today. Engineering physics I did yesterday, and C++ and maths I did a bit earlier only, so that you guys can practice from the practice sheet. So okay, Vardhan, I will upload this PDF once again, and I'll share a whole Google Drive with all the notes of all the subjects so that you guys can find it easily. Any other doubts about exam marking scheme, anything? Your date sheets are out, and even so are your practical date sheets. Then the fees portal is also open, so you can ask anything if you have. Okay, Vardhan, no sir, there is no doubt. Fine, thank you, Vardhan. Anyone else? Whom else do we have? Herman, Keshav, Ram. You guys have anything to ask? If not, then I'll end the meeting. Okay, Herman, thank you. Fine, then I'm ending the meeting now. Then tomorrow again, I will be conducting a session for C++ as well. So, how CGPA is counted? Okay, this is a good question. Look, CGPA is basically the average of all your SGPAs. Okay, kinda. Like your first sem ki SGPA will be multiplied with your first sem total credits plus second sem SGPA into total credits of second sem divided by total credits of first sem plus total credits of second sem. वैसे ही ये इंटीग्रेट होता जाएगा, आई मीन ऐड होता जाएगा. SGPA into total credits divided by total credits का summation. Hopefully it's clear. If it is not, you just text me. I'll show you visually how it is calculated. Like my SGPA in first sem was 7.89 into total credits was 26. Plus second sem mine was 8.67 into total credits was 24 whole divided by 26 plus 24. That is, it became out to be 8.2 something, I guess 5. How SGPA is counted now, for that I have a separate, calculator of my own also in GitHub. I have uploaded it. I'll share that with you guys. Or else you can just ask me personally. I'll tell you. Okay then guys, so I'll just end the thing here. Thank you for joining. Have a nice evening. Goodbye.